Our initial attempt at a moving line was in the original scissors plant, where we installed what is known as the gelota. It was a pace line that moved every 12 minutes according to tack time. The consultants at Shingijutsu told us what we really had was an expensive transportation device that moved our whip from point to point. This was confirmed when I visited Japan on a 3P event last October. I saw example after example of moving lines and their importance to the overall manufacturing process. I also saw the importance of the visual nature of the moving line and its ability to bring problems to the surface. When the line is stopped, it means that we have a problem that must be addressed immediately. The most important characteristic of the moving line that we were really looking for is when it is not moving. It might be a quality issue, a material shortage, or a lack of standard work. Really, the list is endless. In general, though, it forces us to ask why at least 5 times, discover the root cause, and resolve the root cause quickly.
We've been working on implementing a moving chassis line. So I will walk you through what we currently do today. Today, when we pull our chassis up, we put it on to the scissor lift table and we lift the chassis onto our chassis prep area. We usually have one chassis staged at this location, and you can see all of our bolts and everything on the side where all of our parts currently are. And our small parts come delivered actually in the chassis straight off of the E-coat unload area. Our chassis move from the chassis prep area and they move onto the main gelota line. And as you can also tell, we build them upside down for right now. When they come out of the E-coat area, they're built upside down. Currently, the gelota system is a pulse system. It moves to tack time, so every 12 minutes right now. And we add everything to the chassis as it goes down the gelota line. So we add all the subcomponents are basically built on the chassis as we go. And here's a good example. Lots of parts being built physically on the chassis as it's going down the production line. At each station it gets more things added, the brakes, the motors, and it is a multi-model line. So we do build all the slabs, including the 68s down this line currently right now. We have lots of different sub-assembly areas where we do stage things. Obviously we stage huge buckets of nuts and bolts and other things like that. We have also sub-assemblies for like the limit switch tables. All of this again is built a little bit offline, but pretty much everything is built online as the chassis goes down. We have one chassis station and 5 stations on the actual gelota. At the last station down here, at station C5, this is where we actually flip the chassis over and we write it and we put it down on the gelota. It's a very large overhead turning crane, at which time the turntable will match up with the chassis gelota. It will roll onto the turntable and turn and go down to the main line. So this is our current production right now. 72 minutes of lead time through the chassis area. 6 pieces for sure, work in progress. Often there's a couple stacked up at chassis prep, but at least 6 stations. We've just seen the old chassis build-up line, and we are now at the new chassis, basically simulation line. We have gone from a 23-person 2-shift operation, and our new simulation line shows 12 people 2-shift operation, with a reduction of 48% of the headcount being freed up for other areas. Some of the major things that we have done as the parts come in, the existing process has the parts coming in from the E-coat area onto the chassis and then going down the main line like we saw next door. This has them being delivered to an area that's shadow boarded, basically for each part individually. Obviously this is a pretty crude version, but it's each different model, 46s, the minis, the 32s. This is our first sub-assembly area. This area has, as you can see, fixtures and tools. Everything that's needed to build up all of these parts is on this table. This table is one of the major suppliers for the line. And what we've done is we've taken off as much as we can from the main line and we've put it into sub-assembly stations. So as you can see, we've done other things. We've started to play around with signal systems. We've started to, as you can see, have much smaller bins so that we have less, instead of having a day's worth of production, we're shooting for about 2 hours worth of production or half-day production, depending on our supplier. We've done things like make our tools much quieter, have the little holsters right here next to it. Everything is set so you can't make the subassembly incorrectly. Anybody can come in. It's all Poka-yoked, so there's only one way to put things in, such as this. You cannot physically put the hand pump in backwards. It only goes one way, and that's the only way. So we've done things like that we've really been playing with to ensure the quality of our products on the subassembly areas. The next area that we worked on is getting the tires and the brakes off. We've created one-shot installation carts that are designed to roll directly into the chassis. This basically is all loaded up here with all of my parts and everything I need to load up the cart, including all my tools needed for the actual installation on the line. So this is another one of our subassembly areas. The last subassembly area on the aft part of the chassis is our limit switch table, which we saw at the other location. The actual crimper we're going to take from production when we make the switch, but what we've done is we've raised the limit switch crimper to an ergonomic height, so now the employees just stick it straight in instead of reaching down and looking down at table level. We've also can see that we've made the bins a little bit smaller, again trying to reduce the amount of inventory at the actual line itself. All the tools, again, everything's color-coded. This happens to be the orange table, so that everything that an employee needs is right here at the line. And then we've incorporated little things like having the trash bin actually right here as part of the table, so that they can, as they're crimping all their wires, everything goes right into where it needs to go. On the forward side of the chassis, we've taken probably the largest subassembly offline. This is the drive and steering subassembly area, and we're currently finishing up our fixtures. This subassembly will be made on a fixture similar to the other side, and we're currently working that action item right now. This is another tool that we have that we build up the actual cylinder itself in, and again it's bolted to the table. It only goes in one way. All the parts I need are either delivered right to here or they're stocked right here from our vendors, and again all the tools that I need are all color coded for each table to be done here. And then that whole subassembly with all of the wheels and the kingpin, everything gets subassembled together and installed into the chassis in one shot, and our goal is to get the actual assembly onto the chassis to 10 seconds. The moving line itself, when we first started this endeavor back in December when the first visit from the Shingijutsu came, our first endeavor was just to get the line moving, and what we realized was the easiest part of the entire project was getting the line to move. This is our line. It's low profile. There's nothing dug into the ground. It's all above ground, and currently right now it's not even bolted to the ground. Our goal was that at most it would be bolted to the ground, and that was it. It's a completely variable motor. We are able to change the speed of it based on our tack time. Right now it's currently running at a 12-minute tack time. What we were able to do when we pulled off all the sub-assemblies is reduce our work in progress from 6 to 1. We were able to reduce our lead time from 72 down to 12, and basically all the sub-assemblies feeding this one small moving line enabled us to do that. The entire length of the entire chassis line is now 12 feet long, and that's based on the width of our chassis. You also notice our chassis is going down right side up, and it's also going down widthways instead of lengthwise down, and that's to enable us to do the sub-assembly work on either end. The current system allows us to mate up with the current Gelota system. So for right now, we're using a modified scissor table, dropping it onto the roller trays, and then this feeds the Gelota. So we will no longer be using the turntable, and we will no longer be using the chassis Gelota. We'll be removing those and basically matching up with the chassis mainline. To summarize, our new chassis line We are currently at a headcount of 23 team members over 2 shifts, and we are expected to go to 12 team members over 2 shifts for a 48% improvement. We are currently occupying 1,600 square feet. We expect to only occupy 900 square feet, or a 40% improvement. We currently have 6 units work in process at a time. Our expected work in process is 1 for an 80% improvement. Our lead time through our current chassis production area is 72 minutes. We expect that to only take 12 minutes for an 80% improvement. And our productivity per team member is currently 3.4 units per team member. And our expected result is 7.1 units per team member, or 59% improvement. And again, we'd like to have our new continuously moving line, pace to tack time, fully implemented and in production by March 20th.